So before we take up our final review of content in Module 5, and remind me to tell you about the ace in the hole. So there is an ace in the hole with Module 5. We did expand our content and review of material related to memory and virtual memory management and created a new module and had a related assignment and solution. Now, we did experience significant misfires in the serviceability of Windows subsystem for Linux. And this was very frustrating because in previous years, with a little bit of troubleshooting, we were at a minimum able to get Windows subsystem for Linux to function properly, and then we were able to compare and contrast the integration of Linux file system features and capabilities, ext4 and so on, in the context of an enterprise computing environment. So that was something that was a considerable and unexpected setback this year. And I think what we're going to do this next season is basically deprecate any material associated with Windows subsystem for Linux, unless some major improvement pans out with Microsoft. Microsoft is notorious for trying a thing and then it's not quite ready for prime time, and then they come back at it and they improve it and refine it, and then eventually in 3 or 4 generations or versions, they often nail it after some point. But based on what we've seen this season, I would say that Windows subsystem for Linux is not a significant production option. It's not a viable solution for Windows and Linux integration. There are legacy methods to integrate Linux and Windows, and we'll be talking about that in our review of Module 5 material. But I was hoping this would be a segue into Module 5, and that this would be a really cool thing to springboard into 5. And I wanted to express my frustrations and regrets about that one thing. However, all of you do know that in the wonderful world of technology, computer science, and cybersecurity, it's a bit like a Texas two-step. A lot of times you move ahead 2 steps forward, and then there's a step back, and 2 steps forward and 1 step back. And that said, I went back into the Module 4 material and worked some further refinements over the weekend, and I tweaked some of the material in there for better clarity. For example, I found at the bottom of page 1, it was kind of a simple mistake, but it was a incorrect reference to one of our concepts here. So in any case, I went ahead and revised the Module 4 study guide and the addendum. If you happen to have older copies of the Module 4 study guide and addendum, it would be great if you could just discard those and discontinue using them. We do have inside the module, we just did post the Module 4 assessment, and it would be great if you could simply brush up on your review of the Module 4 material and then log a first attempt of this first version before our study day tomorrow is out. So essentially, that's one thing that would be good to finish. Any questions about the expectation for what remains with Module 4 and the updates on the references? No questions? Okay.
No question.
Module 5. So if you've heard the term ace in the hole before, there's a good bit of overlap in the file system review for Module 5 with any of you who have taken systems security. And Luke, did you get a chance? Were you enrolled in system security, or was it just Shanoa and Deanna?
I wasn't.
You were not enrolled. Okay. So this is pretty straightforward stuff. And even if you weren't enrolled in system security, and it's a good bet that by the time you're a senior and you're working 400 level courses, when it comes to persistent memory and disk volume and file system interests, you've had lots of practice and lots of exposure previously to disk and file system concepts, right? So what I'd like to do is hit the high points in our review of disks, volumes, and file system best practices with non-volatile data stores. And I'd like to frame that in the context, not just in terms of efficient access to disk memory, but also in terms of, security and permissions interests. Any questions before we start? There is only one assignment for Module 5. Does everyone see this one word right here?
Yes.
Okay. So the solution option, if you've already engaged system security, you've had some exposure with RBAC, role-based access control, and how granular it is, and how resilient it is, and how it really does help manage efficiently and effectively enterprise network resources, not just local hard disk resources, but across a network, right? So if you have not engaged a role-based access control solution, it would be a good thing to put your hands to it by working through the steps of the 5.1 optional solution. You're basically experiencing firsthand a lot of the concepts and methods that are mentioned in the study guide. Now, if you've already been through that with system security, if you were to basically just review this and decide or opt out of it for yourself, depending on your timeline and how many other obligations you have, I think it's good practice. And I think that there are some benefits to be gained from returning to concepts and practicing again. It basically helps in terms of long-term skill sets where you're not just familiar with it, but you know how to do it and use it, and it's part of what you work in your daily practices. So if you have the time between now and the end of exam week, when we say due 3 December, we mean 11:59 p.m. 3 December. So you can log additional points for additional credit if you'd like. If you have not experienced role-based access control, then you're reading the study guide and you're not really sure about some of the things that are being related, one of the best ways to learn this stuff is to do it. So in any case, it is a pretty straightforward step-by-step process. And if some of you remember last season, there were a few gotchas or a few catches to that process. And might bring a smile to your face if you just kind of spend some time and walk down through that as your time permits. what I will do is factor in the additional credit as an optional submission. So you're not, your final average in the class is not diminished whatsoever if you choose not to submit this. But if you do submit it, it does post as additional credit, so you have everything to gain and nothing to lose. Any questions about the one submission that's expected for Module 5?
No question.
Okay. So I hope you've had a chance to review, at least to scan the study guide and the addendum. What we're going to do is make sure that the most important ideas are called out. There is quite a bit of additional resource from chapters 11 through 16 and the publisher slides. I do not expect anyone, I need to say this explicitly, right? I do not expect anyone to scramble the last few days and hours of our semester to try to cover all that material. It may make sense to look at summary slides at the end, or just I guess there's quick topic slides at the beginning. So yeah, an overview. That's beneficial, but basically much of this stuff is embedded in your study guide. Rather than spending huge amounts of time reviewing the slides, there are special topics on Linux command line interface basics for the file system, for RAID, for Windows versus Linux, and for AD integrated Linux. These are special topics inside the references folder. Inside here, those are things that supplement what's in the study guide, and there is important information in here to take a look at. Most often when we work file system permissions, when we do that on a single client or in a standalone security model, the term that applies is discretionary access control. So the user of the system defines what's going on in terms of user accounts or group accounts. So that's important perspective to understand, since much of our world involves independent or standalone or workgroup systems as opposed to enterprise systems. So, all right, so what we'd like to do, we've already seen this diagram as a mock-up of the von Neumann diagram. I do want to point out that hope springs eternal. I keep thinking that Optane and 3D Point, because it's a combination of RAM and hard disk capabilities, that somebody will come up with a redesign of the operating system and the computing model that's fitting for what Optane and 3D Crosspoint represent in terms of innovation. So is that name ringing a bell? Have you previously heard of 3D Crosspoint and Optane? Good morning, Tommy.
Good morning.
Tell me when the class ends. If you could stick around for a minute, I'll get you up to speed on the first couple of minutes you missed, okay?
Okay, no problem.
All right, so direct memory access was one thing that innovated, basically enhanced the access between hard disks and RAM, so that there's a direct flight between that. Optane and 3D Crosspoint would be yet another, would be a whole different level of innovation. In the Linux world, plug and play really isn't, it's not really a part of how things work. In Mac OS, when you Purchase peripherals and software for the Mac environment out of the Apple Store. The stuff has already been vetted and approved and inspected, and so they know it works with a Mac to begin with. In the Windows world, we have plug and play. And why is this something that matters? Well, in the Linux world, one of the realities of disk access that rears its ugly head from time to time is that a disk must be first attached or mounted before they can be used. This is just one of those things that people forget about. They don't realize that it's a thing, and sometimes you don't have a disk even though you know it's connected physically and you don't know why it isn't working. By the way, if you do decide, and this is just a side note, if you do decide to engage the solution option because you'd like to log additional credit, you would be using the servers that I have ready for remote access. So you wouldn't be using your own server. You'd be using the remote login to perform the role-based access control. Okay, so that is one thing that was worth mentioning here. And all right, so we've already been through what you do when you prepare a disk for use. Everybody understands the farmer's field bulldozing boundaries, playing field index lines, all that kind of stuff, right? Everybody gets that? Any questions about that? And we've already been over slack space, right? Everybody understands what slack space is? We did
Yes, I do.
review RAID in a previous session, didn't we? What were the different RAID types?
Yeah, we did.
Okay.
Yeah, we did.
The difference between network attached storage and storage area networks. And so network file system was the first operating system that was built from the ground up to consider network-based files. But you could argue that Active Directory domains and enterprise environments and with Microsoft is their answer to this. So let's make sure we're not. Everybody understands the difference between file level access and block level access. So one requires an active file system that can speak the same language in order to access disk stores on a NAS. For that reason, you can't use a network attached storage for diskless servers, but a storage area network considers the disk access on the block level or down to the disk sector, basically. So it sees SAN volume as a disk, a hard disk that's connected, right? So when we talked about different access algorithms, the elevator concept, that you're basically working your disk heads like an elevator so that as it's going to and from the different data requests, it's servicing all of those in the same manner that an elevator does, right? So scan and C-scan have been likened to the way an elevator works. Let's talk about Kerberos. So built into the operating system kernel of specific OS environments is a model based on trust. So Kerberos is essentially a method or mechanism to implement or provision trust between systems. One element of Kerberos that is particularly critical is that there's a time synchronization component that's built into Kerberos. And so if your operating system clocks are off by more than a few minutes, you may or may not recall this was something we brought up in system security, but basically there's a synchronization between the systems, and they all have to be on the same clock, the same time scale. If there's too much of a difference, the tickets so Kerberos grants tickets for access. And that's one thing you're going to see when you investigate more about Kerberos. Any questions about Kerberos? Does anyone know why Kerberos, one of the primary motivations for developing Kerberos was there was a common exploit that occurred on computer systems across a network? So in terms of extending the file system so it works across a network, Kerberos was developed by MIT, Massachusetts Institute of Technology, and there was a common exploit that was really wreaking havoc at that time. Anyone? Has anyone ever heard of a replay attack?
Oh, yeah, I have.
What can you share with us what you recall about what happens with a replay attack? So it takes place in
Oh, can you hear me? Oh, I'm sorry.
no, go ahead. It takes place in a network environment. Yeah.
Yeah, isn't it like a authentication, something that deals with the authentication process and it's like retransmitted?
Yes.
I can't
So
remember like the full details, but it's something along those lines.
yeah, it's an authentication attack, and essentially a network sniffer can capture login traffic, and when that login traffic is replayed back, before we had Kerberos, essentially it was possible for people to simply play back a data stream that included a login capture. So person's credentials would be presented and then their password characters, and then they'd float right in. So a replay attack was pretty bad. And for a long time, that was a serious threat. So one of the aspects of security and access, controlling access, is the idea of authenticating user accounts. And if you remember from system security, user accounts are nothing more than a logical representation of the actual physical user. But one Achilles heel is the idea that hackers can easily determine what your user account is just from looking at network traffic by embedding time signals. When a replay occurs in a Kerberos environment, the timestamp associated with that replay is off. So it's refused, which means that authentication is broken. And that prevents a replay. So did we get into journaling? A journaling OS? I don't think we've gotten this far. So, well, let's see, we have 6. Oh, Shanoa twice. Shanoa, you're in the session twice. Did you need a second client in the session?
No, my computer was acting up. I was just about to log off from the computer.
No, that's okay. Yeah, I was just asking. That's fine. Not a problem. One of the things that becomes a challenge for operating system design, when you look at all of the different levels of control, right? So you have process and calculations. So you're controlling processes, you're controlling memory access, you're controlling virtual memory access. You have all of these different interests happening at once. For the longest time, system crashes were very common. And it became obvious that an operating system needed to include the ability to log or audit much of the system internals, right? So when debugging and conflicts or crashes occurred, there was some basic point of reference. The thing that's not as intuitive about how this works. So file systems have to include additional criteria in order for logs to capture detail about file system operations in order for them to audit. So when you're logging these things based on specific criteria, logging events based on a specific criteria would be what we mean by the word audit. So the features and attributes of a file system that empower journaling, which is another fancy word for that, logging and auditing. The features and functionality of a file system are what make that possible. Now, in older versions of the file system, for example, the file allocation table, right, FAT, as an old DOS throwback. These older file systems essentially did not include journaling attributes and criteria. So, you didn't have as much information about the things that would clash or crash when those happened. Essentially, the choice of file system has a profound impact, and there have been new versions of file systems. So NTFS includes some additional capabilities as a file system. And what I'd like to do is spend a little bit of time sharing one of them with you that's not so obvious. Have we ever talked about dynamic disks before?
I don't recall.
Okay. Well, when you're setting up a partition, a disk, an operating system configures what's known as a partition table, yeah? And there's an older legacy version of a partition table called a master boot record, MBR. And essentially, there's a newer flavor of partition. It's called GPT. That stands for GUID partition table. It's an extension of the legacy partition table that allows for very large disks. So just remember GPT. Can everybody see here basic? The word basic.
Yeah, we can see it.
Okay. So traditionally, whenever you're preparing a disk for file system use and you're establishing and preparing it, you initialize it and then partition it. The conventional methods of storing that information near the front of the disk, the geometric and physical front side of that disk, And for many decades, that's referred to as a basic disk. Now, you can, with the NTFS file system, you can convert this to a dynamic disk. Now, a dynamic disk takes the file table, the partition table, and the file system table, and it changes the format so that it's redundant and basically utilizes like a database format. Think in terms of like access. If you had an access database that was configured exclusively and specialized for redundant entries for file system and partition tables, it converts the disk where it removes the partition and file system table from the front of the disk, and it creates duplicate copies in a database format that are stored toward the end of the physical disk. Now, this becomes a challenge for other file systems that are trying to access a physical disk or to interact with the file system, especially when you're dealing with data recovery scenarios. So that's one aspect of this that's really important. But a bigger benefit of having a dynamic disk, see, we can convert it from an MBR disk to a GPT disk. It's already a GPT disk, so that's why that's grayed out. When I formatted my solid state hard drive for this laptop, I chose GPT, basically. So it's not an option for this disk, but that has to do with the partition table, the style or type of disk that's initialized. When it's a dynamic disk, if you convert it to that, having disk volumes converted to dynamic disks allows Windows to create software versions of RAID. So what am I saying? I can create virtual hard disks and then format them and turn them into dynamic disks, and I can pair them in a mirrored configuration or a striped configuration. It's all software mediated. It's not physical hardware based, but it's software based. And so this is one aspect of the new technology file system. So NTFS literally stands for New Technology File System. And it came about with the introduction of NT 3.1. There was a collaboration between IBM and Microsoft to produce a workstation class or server class of Windows operating system that they called NT. And the early versions were just called NT. And then eventually, when a directory was included and there were upgrades to a domain environment, they transitioned from NT into Active Directory. So around the year 2000, that's what happened. Why should you care? Well, a lot of additional features were added when NTFS was retooled or redesigned for an Active Directory environment. And those include things like the ability to integrate file compression or encryption into the Active Directory environment. And Macs have added some additional features. Linux variants have added ext4. Each of these latest versions of the file system, in theory, are supposed to make interoperability in an enterprise environment easier to accomplish. But there are some profound wrinkles, like when you're using HFS Plus on older Macs, some of the character sets are different. And that literally causes problems or misfires, right? The important thing to understand is that a journaling OS is the foundation that allows an operating system to be able to log and audit very, very detailed information So much so that you can capture so much information, you can crash a system. So if I'm looking at my event viewer on a server and I turn up all the logs to save everything, basically what will happen is that my event logs will increase in size until all the disk space is consumed and exhausted. The important thing to understand is that with a journaling log system, you have to watch log sizes. And this is a performance and OS maintenance concern, but basically, if I had my security log and my setup, my system log, security log, and application log tracking everything, if I turned up all the dials, essentially, those logs can be consolidated, but quite often they're stored locally. And there are settings for each of these that you can configure. And what's important to understand is that in the properties, you can set this. Does everybody see this?
Yeah.
And see this option where it says overwrite events as needed, oldest events first? That's the default setting, right? That's like a 20 megabyte file. And if you were tracking more, if you were auditing more in an operating system because you were developing new components in an operating system and there was a lot of activity, a lot of bugs you were tangling with. Here it says archive the log when full, do not overwrite events, right? So you can save backup copies. Another option is don't overwrite events. So instead of cycling the log entries when you're auditing, when you're journaling an operating system that's working furiously, if this setting is in place, when the log fills up, the OS stops working. Let me repeat that. If this option is set and the size is exhausted, even if you have extra disk space, if that log is full, the operating system will come to a screeching halt. And that includes especially servers where there are thousands of users on there. If you do not overwrite events, it means you have to do something with the full log. You have to back it up, you have to copy it, you have to clear it manually. And if you don't, it basically freezes. The entire operating system freezes. So that's just one consideration that's important. But the other thing that's probably the most important, and this is just, it's not a very intuitive kind of thing. Let's take a directory I have here. And let's go into my properties. Can everybody see for security here, advanced? This is a pretty familiar screen, yes? Hello? Does this look familiar to people? Kind of, sort of, maybe?
Yeah.
All right, so when you're configuring permissions and inheritance and that kind of stuff, the important thing to remember is that if inheritance is in effect, it's receiving the permissions and who has which privileges, which accounts are in the mix from the parent directory, the one above this directory. So the parent directory, what's the parent directory for the temp folder here, or the temp directory?
C drive.
It's the C drive root, yeah, the root directory. So we would call that single backslash the root of the C drive, yeah. So it's the root directory of the C drive. And of course, in Linux, we don't have drive letters. Now, here's the part that most people don't pay any attention to at all, okay? And the important thing to understand is that journaling in an operating system requires two steps. The first step is to configure what events will be audited. So if you were to configure in security, you know, failed attempts at logins or failed attempts at file access, right? If somebody were to try to access a directory and they had to put in a password to access it and it failed, that would be a failed access attempt of a directory, a file system object, right? So the first part of the process is to enable a specific event, a specific type of action or event in terms of the operating system. So what you need to do in the first task is to enable a specific event or action, auditing for a certain type of event or action. The second step is to go into this tab and then to select the file system objects, the disk drives, the logical volumes, the directories, the data files. You go into this tab and you enable auditing of that specific file system for that event. So the first thing you do is you decide, okay, what am I going to log? What types of activities and events am I going to want to capture? And then the second step is to go into the file system level. And in order for journaling to work, you have to go in on auditing and continue and select, okay, which logging options apply to this specific file system object. So now that you've defined what it is you want to track, you have to assign which of those functions you want active for that specific file system object. If you don't take the second step, it doesn't work. So what am I saying? One frustration that people have with journaled operating systems is they go into a policy editor. So it could be something like let's see. Could be the local group policy editor, and they could configure auditing features inside here and make it policy and enforce the policy against that system. And they go to all that trouble to define the event and the activity they want to log, but then they do not go into the file system for each of the file system objects and then select which of those actions and which of those logging options apply to that specific file system object. So just remember that it's a two-step process. And if logging isn't working, it's likely because people set up the logging interests they wanted, but they didn't tell the operating system, okay, where do these apply? Where do I apply those specific interests? Because you don't apply a given logging interest to every data file and every directory on an operating system unless you're in an extremely high security environment and you set up your logs so that you can greatly increase the storage capacity for that log, and you tweak the settings so that they're not overwritten. Any questions about auditing? So that's where we talk about the file space running out. Okay, role-based access. So Luke and Tommy, you were not with us for system security last season, correct?
Correct.
Correct.
Yeah.
So essentially, when people are in here in the weeds and they're configuring permissions, security permissions on a specific directory or file, when a user is doing that, that's commonly referred to as discretionary access control. The users of the system are the ones that are deciding. They're the ones with the discretion about who has what privileges and rights. And so they're assigning those to specific user accounts or groups. In a role-based scenario, you have an enterprise environment and there are defined roles of responsibility for users. And those roles become the basis of creating security groups. So you create security principles, more specifically security groups, that represent a given role or responsibility. And then in order to implement this file access controls, so that they're, you know, very cleanly and very precisely controlled, you basically put users into those groups. So you assign users to a given role or security group. And a role is defined in the file system as a security group, or in Linux as a user group, okay? So you never assign, if I assign security permissions to a specific account directly, and the user is doing that based on that account identity, that's discretionary access control, and that's what we do every day, all day long, and no one thinks about it, right? In a domain environment, when we're working role-based access control, there's coordination with the stakeholders in your enterprise, in your organization, and you define who it is that performs which roles and responsibilities. A security group, a security principle is created to represent that role. And there have to be sensible directory names for file system objects that track with those group names, okay? That map and correspond to specific security groups. For example, if I had an accountant's role, I might have an accountant directory, and I would also have an accountant security group. I provision permissions, I configure permissions by assigning the permissions to the role or the security group, never to an individual directly. So how does a user gain access? You make them a member of the security group. When they leave that role or transition out of that role, or others come into that role, even temporarily, all we do is change the membership of the security groups. Am I making any sense? So that's what the solution is about, and there are some corresponding videos, and there's also some additional resources in here under the references and special topics. It talks about RBAC. Now, true or false, you can or cannot implement RBAC in Linux. True or false? Well, okay, it's right on the screen. I just want to call that out. You can implement RBAC for Linux and Mac clients. The setup is a little different, but basically the overall tasks work the same, okay? So privileges are associated with group membership. So when somebody is said to have different levels of privilege in an OS, that has to do with the type and membership of security group they belong to, as opposed to permissions. Permissions are attributes of file system objects that we configure that tie back to the user accounts and groups, the security principles. So there are several examples of this kind of stuff, and a lot of this is intuitive. In a Linux system, you'd be dealing with membership to the root group or super user. Super user privilege is a function of being a part of root. One of the things that happens when you're working network permissions and you have file system level permissions, there is a net permission that results. So you can have NTFS file level permissions on the disk, and then you have network share level permissions. Those work differently, but they tend to combine, and that's what's called effective access. Is this ringing any bells with folks from Ringing any bells?
Yeah, it is.
Okay, I'm glad to hear that. So if I share my temp folder on the network, another issue of sharing on the network, you'll notice that I've added a $sign to the end of the share name. Another pitfall or common pitfall is that if you have a directory name like this that has a space in the middle, program space files, and then you try to share that, there's a lot of things that break on network sharing permissions and network shares because of the space. It doesn't like spaces. So one thing to do is to keep the name program files, but put an underscore where there's a space so that you have characters straight across, but always add a $sign. What does the $sign do for us? Does anyone remember?
It hides it.
It hides it. Yeah. When it comes to network browsing, there's a service that when hosts are connected to a network, there's a service that runs called Discovery. People like to browse the network, and it's not a very common thing that people get into necessarily. But if you scroll down, you'll see here it says network. And if you click on the network, you can see connected devices on the network. If there are any directories that are shared and they're not hidden, you can basically browse to the system and then click on it and then browse into the directories. You can get into people's Kool-Aid very quickly. So this is one of those issues. But the other thing that I would share with you about this is that when you're sharing, there are network level permissions, and the default for this is horrific. So the default for network share permissions is everyone read. Everybody sees this?
Yeah.
And they do that.
Yeah.
If a Mac user or a Windows user just wants to share something on a network, they don't want folks to have to call tech support all the time. So the default setting is, okay, if they intend to share something, the default does not put a $sign on there. You have to manually add that. And then the other thing that's a default is that the everyone group, which is the Linux equivalent of what group? Does anyone recall their Linux file system? Special topic in here in references. Special topics. I hope you spend some time brushing up on Linux, Windows versus Linux. And then file system objects and the Linux CLI. This is a good one right here. I want to make sure you get in there. What were we just asking? What is the Linux equivalent of everyone? What is that group called? It's the other group. So if you create a directory in your user profile in Linux, you will be the owner creator, but then Linux will also automatically create a group with the same name as the user. If you're not a part of a group, if your user account in Linux is not part of a user group, different animal than security group, but similar functionality, right? You can create multiple groups in Linux. It's just not as intuitive. The world of Linux revolves around the owner permissions, specific group permissions. So you assign a directory or a file system object to a group. If you don't do that intentionally, it just automatically creates a temporary group with the same name as the user, and you're the only account in that group. So if you pull a directory listing in Linux, you'll see double entries of your name, your name, your name, your name. Well, one is an account name and the other one's a group name. The last category is called other, as in every other person on the planet. So everyone is the equivalent of other in the Linux file system. Okay? Everybody got that?
Yeah.
Yeah.
Now, I want you to notice that the file network level permissions are broken out differently. Full control, change, and read. And those are legacy permissions. So what do we mean by legacy? For the sake of compatibility, backwards compatibility to old file share systems like LAN Manager and SMB, network file sharing kinds of things, you have full control, change, and read. When you're looking at file level permissions, file system, on the file system, those you'd have full control, and you wouldn't have change, you'd have modify. And if you select modify, typically the write option enables with it. So if you modify and write, that's the same as change. And then read and execute is the same as read. So if you have read permissions across the network and you want to execute something, that works. But on the file system level, it's a lot more granular. The other thing that's important too is that they have special permissions like traversing the directory tree. Those are really important things to understand in a high security environment. The other thing that's important to know is this idea of ownership. So ownership is consistent for the sake of POSIX compliance or POSIX compatibility in the Linux environment. You do have a defined owner of a file system object, a data file or a directory. It's the same is true in the world of Windows or in the Mac OS. You have this other criteria known as the owner. So someone is a creator owner when they create something. So if I go into here and I create a temporary folder called stuff, and then I look at this, and I go into properties, and I look at security, the owner is the person who typically created this. On the server file system, you see the term creator owner and not just owner. In any case, notice that I'm inheriting the permissions from temp, right? So one of the things that you do when you're working role-based access control is after you've created the security groups and directories, you apply the NTFS permissions by using groups. You never list a single individual account, always a group. And the groups are listed here. And what's important is that you turn off inheritance from the parent folder above, but then you check this box. So you push those settings into the subdirectories and data files below. So it's a kind of it's a hard stop for permissions flowing down from the parent folder. When you disable inheritance, that's what you're doing when you click this button. So if I do this, it says, what do you want to do? And if I remove all inherited permissions, this is what the stuff directory has now. It has no permissions, which can be a problem because if I don't change anything, the system can't access it. The computer account can't access it. Even the owner cannot access it, right? Now, the user account I've called owner, that is the owner of this particular directory. So that can be a little confusing, creating a user account called owner. That's an attractive nuisance, and in terms of cyber, you never want to create the root account name to be something that's attractive and intuitively privileged, right? So owner would be a very piss poor choice of an account label. But for added security, you can always create security principles with names that don't track with common identities in the physical world, or with the roles and positions in an organization. You don't need to create an account that's called Chief Financial Officer. Just don't, right? And don't create an account with the name of the Chief Financial Officer, because any hacker is going to look at that and say, okay, I know that's where all the money is. That's where all the cheddar flows. So I'm going to be paying attention to the CFO account or the, you know, the name of the CFO. They can look up on Facebook, right? Or Snapchat or TikTok. By the way, has anyone ever seen has anyone seen recently the concerns that the US federal government is sharing about TikTok and how it's controlled? Still,
Like China or something like that?
yeah, it's still controlled by members of the Chinese Communist Party, or CCP. So the data that's flowing into TikTok about your usage patterns, it's being collected by members of the Chinese Communist Party. So the Chinese government officially denies that it's doing any of that. But what's happening instead is that the members of the Communist Party themselves who were involved in that enterprise are actually collecting all the data from TikTok, which is just another way of lying about it, right? Now, if I go into here, I've got, because I'm the owner, I can get in there. But anyway, the rest of this is pretty straightforward stuff. And in the Linux environment, when you're using terminal, you should use SSH to connect. So this is just a quick primer on stuff you need to know about. I'm going to try to trick you about changing permissions using the change ownership command. And, you know, there'll be a module assessment item that says, hey, this one command isn't working to change the permissions of a directory. What's going on? And you'll see in Linux, that's the change ownership command. This is the change permissions command, permission mode, right? You change membership in groups by using the user add, group add, user mod, and groups commands. So there's a quick explanation of all that. This is one area that I think I'm gonna wrap it up now. So we're near the end of our study guide, right? And the thing that I want you to understand, AAA means what? Does anybody know what AAA means? Authentication, access, and auditing, something like that, right? So this is an important section because it talks about the current methods used to integrate Linux file systems with Windows file systems with Mac file systems. And I have a proposition for those of you that have Macs. So who among you have Mac clients? Anybody? No. You have a Mac client? Was that Luke?
Yeah, I'm on a Mac.
Okay. So you can work through the Module 5 solution option, just the way it is. And just follow the steps in the video. But if anyone is interested, it would be pretty cool to join a Linux system to the Active Directory domain, or to join a Mac to the Active Directory domain that we have established remotely online. And once integrated into Active Directory, it would be really cool to see how the security principles flow between those different kinds of operating systems. Now, why would you care? If you've never done something like that, it's a little tricky, but it's sort of, it's the equivalent of bragging rights. If you're a systems engineer or you build enterprises or whole data centers that support, I don't know, countless numbers of organizations, people need to be able to interoperate. This one section is something you need to spend some quality time in to understand each of the 4 possibilities for integrating Linux file systems, Apple file systems, with NTFS and Active Directory domain. Essentially, you can use virtual machines, you can use integrated Linux functionality components like WSL or Wine. So Wine lets you run Windows programs in the Linux environment. WSL, in theory, when it's working, allows you to work Linux command line stuff and software in the Windows environment. One limitation about WSL that's significant is that when you create a WSL installation on a Windows system, that's only valid for the logged in user. It does not exist on a lower level for the operating system as a whole, but only within the user profile of the account that's logged in. So put another way, in Windows, you can have multiple instances of WSL running based on who's logged in. So that would be something that gets pretty confusing pretty quickly. Samba is sort of like an industry standard. What it is a middleware. Well, it's an application that sits between, and it basically brokers file level access so that it honors the security principles, the user accounts and security groups or user groups. And then of course you can join a Linux client or a Mac client to the AD forest directly. So in previous years, your colleagues, your predecessors have done all of these, right? To date, none of your predecessors have ever attempted to join a Linux or a Mac to an AD domain as a capstone project. They've just gone ahead and done the RBAC. But if you've done the RBAC before and you're looking to do something different and you'd like to log some additional credit, that would be a really cool thing to do. And you have the systems set up. You have a ready-made Active Directory domain. And there are some very basic ways to do that. So you can establish the equivalent of a domain in the Linux world called a realm, and then create a trust between the realm and the domain. That's the other way to do this. So you create a whole separate infrastructure for Linux and Macs, and then you get the domain and the realm to trust each other. That's forest level integration, okay? Using trusts. So I think it would be pretty cool to try to see if support for other operating systems has improved with Server 2022. I haven't had a chance to check it out yet, but if any of you are interested, please let me know. So the idea of a domain tree is basically the same kind of thing as domain name service. If you remember domain name service, it's pretty much the same kind of thing. All right. That's it. There's just a few more points here. And the last ones are highlighted in yellow and red. I won't read them to you. Does anyone have any questions or comments before we clear? Okay.